example 2, what we're going to use as a better strategy than a table of values that'll give us a really accurate graph with relatively little information is the following. We're still going to use the end behavior, but we're also going to find all x and y intercepts. And if we have all the x and y intercepts and the end behavior, we are going to be able to draw a very accurate graph. So what does it look like? Well, first of all, we look at this question and say, can I figure out my end behavior? Yes, it's an odd function with a positive leading coefficient. So I know my end behavior looks like this. Next, of your intercepts, your y-intercept is always the easiest to find. You find a y-intercept by plugging in 0 for x. So it's a bit like a table of values, because you are plugging in a value. You're plugging in 0 for x, and 0 plus 0 minus 0 happens to be 0. So we get 0, 0 as our y-intercept. Our x-intercepts, they do take a little bit more work, because you find an x-intercept by plugging in 0 for y. And then how do you solve an equation like this? You solve it by factoring. And everything we did in 1.1 and 1.2 was learning how to factor things that were bigger than x squared. That's what we're going to use now. Now, unfortunately, this example, you can factor too easily. I missed it. There we go. You can factor this one too easily because there's an x in all 3 terms. So if there's a common factor of x, I can pull that out to begin with. And then I can factor this because it's just a regular quadratic. 2 things that multiply to give you 6. It's going to be 3 and 2. The 3 is positive. The 2 is negative. And we got 3 x-intercepts, x equals 0, x equals negative 3, and x equals 2. Well, the 0, 1 is 0, 0. We already found out that's our y-intercept. We'd also have negative 3, 0, and 2, 0. So now when we go to graph this, we've found all of our x-intercepts and our y-intercepts. Y-intercept 0, 0. X-intercept 0, 0, negative 3, 0, and 2, 0. And anytime you graph, you have to make sure that you provide a scale on your x-axis and your y-axis. Usually this can be done by labeling your points. But if I labeled the points here, I wouldn't have anything on my y-axis, so I just labeled it 1, 2, 3. I have all my points. I have my end behavior. My end behavior says you start down here and you end up here. Yes?
It says in the description, just sketch.
Yes.
We also have to write a scale if it says sketch.
Even if it says sketch, you have to have a scale. Yes. So, anytime that you're drawing, they do require a scale. What they won't require is the following, okay? Once you have your x-intercepts, y-intercepts, and the end behavior, you just have to draw a smooth curve going through all of these points. There we go. Now, what you won't know is that point right? Did I go high enough? They actually don't care. That's grade 12. Once you get to calculus next year, calculus is going to worry about how high that goes there and how low it goes here. Because it might go lower. And you could do a table of values to see how close was I. But for grade 12 pre-calculus, or the sketch, if you have all the right x-intercepts and y-intercepts and the right end behavior, they're going to say it's okay that you're not quite perfect for how high it goes and how low it goes. This gives us a really good idea of its shape with relatively little work. Okay? Now, this question here was too easy for us because the factoring was too easy. More typically, you're going to get questions, and we're going to go back. We're going to go back and actually do example 2 together. More typically, you're going to get questions like this. So you don't have to write anything down because the textbook has it written down for you, but I'm just going to walk you through what a more typical question looks like. Okay? Just like before, you're going to start off with your end behavior. This is an x to the 4 graph with a positive leading coefficient. It's going to act like a parabola. There's your end behavior. Next, you're going to find your intercepts, starting with your y-intercept, because it's super easy. Plug in 0 for x. 0 minus 0 minus 0 plus 0 minus 6 is minus 6. And your x-intercept, this is where there's going to be some more work involved. You plug in 0 for y. And you have to solve this. And you're going to solve this by factoring. So for factoring, this is where we have to use our factor theorem, factor property, remainder theorem, synthetic division, everything from 1.1 and 1.2. So, how do I factor? Well, I first need to find one factor that works. As far as finding one factor that works, I look at the last number, which is a 6, and what are things that multiply to 6? 1 and 6, or 2 and 3. So there's really not that many to check, but it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Since we have the notes there, we're going to pretend we were very smart and got lucky, just like the textbook, and tried one first. Okay? Sometimes you're going to get unlucky and try one that doesn't work first. Sometimes you're going to get extremely unlucky and try one that works, but make a mental math mistake and think it doesn't work. I'm going to tell you, that's going to be the most frustrating thing. Because then you're going to spend the next 25 minutes convinced that there's another one that works when you've already missed the one that works. But usually there's more than one that works, so you should be fine. So if we tried 1, we're going to set up our synthetic division. 2, negative 1, negative 14, 19, and negative 6. Bring down the 2. Multiply, add, multiply, add, multiply, add, multiply, and add, and sure enough, we get a remainder of 0. So this is good because now I can rewrite this equation that was 0 equals. I can write, usually in 1.2 we wrote p of x equals, but we don't have p of x equals here. Now we have 0 equals, so we write 0 equals, one factor was x minus 1, and now we have 2x cubed plus x squared minus 13x plus 6. And we've started to factor this. We still need to factor even more because this is still an x cubed. So we would say, once again, the last number is a 6. We're going to try and figure out a number that works. Could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We're going to cheat because the textbook tells us already, hey, you should try 2. Okay, bring down the 2. Multiply, add, multiply, add, multiply, add, and once again, perfect. You get a remainder of 0. So you take this equation, 0 equals. We still have the x minus 1 factor, but now you have an x minus 2 factor, and what's left is 2x squared plus 5x minus 3. And once you get to an x squared, now you can just factor like normal, it's gonna be 2x and x to get 3. I'm gonna put the 3 and the 1 there, so my outside is 6, my inside is 1, so I want positive 6 minus 1. And it's factored completely, which tells us x equals 1, x equals 2, x equals 1/2, and x equals negative 3 are our 4 x-intercepts. So now when we go to graph this, we found all of our x-intercepts. Yes, it is a little bit long to find the x-intercepts, right? We had to use synthetic division and factor it completely. But now that we've got all of our x and y intercepts, I'm going to have to go down even further here. 6. Y-intercept at negative 6. X-intercept at negative 3, 1/2, 1, and 2. Again, technically this would be enough for labeling, because I've labeled something on my x-axis, something on my y-axis. It's not bad to label a few more points. Label that one as well. But you need to have something so that they know what scale you're using for both the x and the y. The end behavior of this one was a positive x to the 4, so I know that it's got to have this at the end. And now I just need to draw a curve that fits through these points as best as possible. Now, a thing that I see often that loses mark, here I'm going to show you very typical lose marks in this situation kind of thing. They're like, you are trained from an early age with dots to connect them. Okay? You connect the dot things, you just draw straight lines to them. So you're going to lose marks if your lines are straight like that, jagged points. A polynomial graph is nicely curved. Okay? So we'll have that go away. Another way that you're going to lose points is you're going to be tempted to do this. Whoa, I went too far. There we go. Right. Woo! You cannot go back in time. This will lose points. Okay? Generally, if you have your x-intercepts, your maximums and minimums should be somewhere in between. Not perfectly in between, but close. So this one, to draw it nice, it would probably be that the minimum is not at the negative 6. You're going to be tempted to connect those points, but the minimum probably would drop down somewhere in between there. And then your curve is a nicer, smooth curve through all of them. And this is your final graph. Okay, questions for practice on this one are 7 and 13.